Okay, good day. I'm now going to show you how to calculate for shapes and space. Okay, so we'll be dealing with shapes and spaces. Now, when we consider shapes, shapes are diagrams that when drawn, the starting point must actually meet the end point. So if I'm about to draw a diagram, this would be my starting point. It must meet the end point, and this would be considered a shape. So this is my starting point, and I'm going to meet the end point. That is considered a shape. So the starting point must always meet the end point. Then that would be considered a shape. Okay, so those are shapes. We actually have two types of shapes or dimensional shapes. We have two-dimensional shapes and a three-dimensional shapes, right? So someone would say, what about one-dimensional shape? Okay, we cannot have one-dimensional shape according to our definition. The starting point must actually meet the end point. So if we had a one-dimensional shape, it actually referred to be a line. So you see, the starting point does not meet the end point. The starting point does not meet the end point. Therefore, this cannot be considered a shape. The starting point does not meet the end point. These are actually lines and curves, and they have their own names. But since the end point does not meet the starting point, therefore this cannot be considered as shapes. Now let's look at two-dimensional shapes. When we actually talk about two-dimensional shapes, they are referred to two-dimensional shapes because you'll be dealing with two dimensions, which is the length and your width you see. So this is where you'll be calculating either for perimeter or for the area. Okay, so those are your two-dimensional shapes. And the three-dimensional shapes, they are referred to as three-dimensional shapes because you'll be dealing with three dimensions, which is your length, okay, your width, and your height. Okay, so those are the reasons why one would be called three-dimensional and other one would be called two-dimensional. Okay, now so two-dimensional shapes actually have what we call a flat surface. Okay, I've indicated that you can calculate for perimeter and for area in two-dimensional shapes, and they are named according to the number of sides they have. Okay, so if you look at the first shape, this would be your triangle, which means three. You have three sides there, and then you have your 1, 2, 3, 4, 5, 6, which means you'd have your hexagon. It has 6 sides. It will represent the hexagon. This one has 5 sides. It will represent your pentagon, and then this one is your rectangular. That would be your circle, and that would be your square. So these are the basic shapes that you actually meet most of the time. So hence I've indicated that these are the two-dimensional are flat surfaces, which means they do have the vertices and they do have the edges, but they only have one face. Okay, we'll come to that later. And now let us look at our three-dimensional shapes, right? Our three-dimensional shapes, it's actually a combination of the two-dimensional shapes to form an enclosure. You see, these are our two-dimensional shapes. For example, if I take 6 of these two-dimensional shapes and combine them all together, I'll have something like this. 1, 2, 3, 4, 5, 6. As you can see, those are my 6 two-dimensional shapes combined together. And if I close them up, I end up with a cube. which means if you take your two-dimensional shapes, combine them up, you end up with a three-dimensional shapes, okay? And in this case, three-dimensional shapes, you will be expected to calculate for the surface area and the volume. Now, normally it would be a total surface area. In order to calculate for total surface area, you need to create a net diagram like this. They actually give it to you in this format. Is either a prism or a pyramid. They give you the object in this format, and then you, in order to calculate for surface area, you must open it up and make it a net diagram. Now, there are formulas on how to calculate such. We will deal with such matter when we get to the calculations in measurements, but you notice you'll be dealing with length times breadth, about 6 of them. That's what makes the total surface area. Now, the three-dimensional shapes, you'd have something like this. This would be called a triangular prism. This would be called a cylinder. This is still a triangular prism. Oh, this would be your pyramid. It's not actually drawn very well, but this is supposed to be your pyramid. And then this would be your cone. This is a triangular pyramid. This would be a cone. So you'll realize that I've introduced two new words, which is the pyramid and the prism. Now, the pyramid depends on their base, right? They depends on their base, which is always two-dimensional shape. If you take all the two-dimensional shapes, you can convert them into a pyramid. For example, I have this one. In order for this to become a pyramid, all these points must meet at one vertex. So this becomes a triangular pyramid. If I have my circle, which is a 2D shape, and I make 2 points that will meet at one vertex, then that becomes a cone. If I have my square there, this automatically becomes a base, like I've explained. So I make all the vertices to meet in one place, then that becomes my square pyramid. Then this is my pentagon. So the base is pentagon. The name will also have a pent in it. So I make all of these vertices to meet at one point. Then this becomes a pentagonal pyramid. Okay, so let's look at a prism. A prism is actually an elongated 2D shape. Okay, by elongated 2D shapes, what I mean is, if I have my two-dimensional shape here, my triangle, if I elongate it, I'm gonna have something like this. Then this becomes my triangular pyramid. Now I have my circle, and if I elongate my circle, this would actually become a cylinder. Now I have my pentagon. If I elongate the pentagon, okay, elongating the pentagon, where does this one go? Okay, then this becomes my pentagonal prism. Then if I have my square or rectangle there, elongated, this is what I end up with, a rectangular prism. Okay, now all these objects, the pyramids and the prism, they have these things, as I've explained. They have the faces, the vertices, and the edges. I've explained that in two-dimensional objects, you only have one face. So in this case, when you deal with three-dimensionals, you will have more than one face. Okay, the two-dimensional only has one face, but it has your edges and it has your vertices, and then your 3D has more than one face, and it also has your vertices and your edges. Okay, so now an edge is a line segment joining two vertices. Okay, so if you look at our 2D shape here, I have this line segment. This is the line segment. It's joining two vertices at these 2 points. So this becomes my edge. So in this case, I have 1, 2, 3, 4, 5 edges. Okay, so you see that this line here joins these two, this line joins these two, this line joins these two. In which case I'd have 1, 2, 3, 4, 5, 6 edges. In my triangle, I'd have your 1, 2, 3 edges. So you get an idea what an edge is. But normally we'd give you a 3D shape and ask you how many edges are there. You notice it is the line that joins two vertices, right? These points here are my vertices, okay? So it means I will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges on my square there. Okay, before I continue, let me explain to you vertices. So a vertex is where two or more lines meet. Okay, a vertex is where two or more lines meet. In this case, you look at my 2D shape here. I have this line and this line, they meet here. That makes it my first vertex. I have this line and this line, they meet here. This is my second vertex. This line and this line, they meet here. This is my third vertex. Then this line and this line, they meet here. This is my fourth vertex. Therefore, this means that I have 4 vertices on a rectangle. Okay, so if I have 4 vertices on a rectangle, let's check this diagram here, because we normally give you 3-dimensional shapes, right? So in your 3-dimensional shapes, I've explained that a vertex is where 2 or more lines meet. In this case, we have this line and this line and this line. These are 3 lines. They meet here. This 1, 2, 3, they meet here. These ones, they meet here. These ones, they meet here. These ones, they meet here. And these ones, they meet here. So it means I actually have about 6 vertices. And then if you figure out your vertices, then it's easy to find your edges. Okay, your edges would be this line. You see, this vertex joins with this one. Therefore, this line segment, this is my edge number 1. The line segment, this line joins here and here. This is 2 here and here. This is 3 here and here. This is 4 here and here. This is 5 here and here. This is 6 here and here. This is 7 here and here. This is 8, and there is that one at the back there. Can you see it? Here and here, which makes it 9. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 edges on a triangular prism. So the last one is a face, or we call it faces. Face. They would ask you how many faces does a diagram have? Now a face is the flat surface area of an object. Like I've explained here, in my 2D shapes, they only have one face. Can you see that? It's only one face. Therefore, in my, if I convert this, when we do this, into a square prism, and I want to know how many faces I have. Okay, now I'd have to take this and make it a net diagram. See, I've opened it up and made it a net diagram. Then I'd have how many faces? 1, 2, 3, 4, 5, 6. You see, they're basically asking you how many squares are there when they say how many faces are here. Okay, the flat part of the area, the flat part of the object becomes your face, right? So you don't actually have to open it up like this, but you can actually figure it out. I will later show you how to figure a simpler way of figuring it out just using numbers. Okay, now because my square would have 6 faces, the upper one, the bottom one, the front one, the back one, the one on my let me call it my left, and the one on the right, which is behind. Okay, so for example, let me figure out another object. Okay, this is my square pyramid, right? My square pyramid would have how many faces? Let's first draw the diagram. This is my square. Okay, I'd have this pyramid, I mean this triangle and this triangle and this triangle. Remember, I said all these are made up of 2D shapes being joined up together. They make 3D shapes. Okay, so they've joined up a square and how many? And 4 triangles. Then how many faces do I have? I actually have 1, 2, 3, 4, and 5. So it means in this diagram I have 5 faces. If I close this up, it becomes like this. Okay, so in order to actually figure it out, you also can open your object and make it a net diagram to figure out how many faces they have.